function 1. Okay guys, so if you see the Dropbox, for those who have installed, we basically, the date of today is May of 6, but since we went slow through yesterday's lecture, right, I am basically doing the lecture 2 only today, right, function call and order, which is of May 5, and I think we are still left with that. Okay, so we will start the questions from there, right? So welcome again class. So in this class, we will just see ki, okay, how can you work with arrays and functions, right? Till yesterday, we were seeing some basic variables. For example, we were just passing a and b, like 5 and 3, and then computing something in the function. Now we will see how to pass an array in the function, how to pass an array or how to pass array values specifically. Fine. So now let us start this code. Okay, so now if you can see, I have an integer array here with 2, 8, 4, and 12, right? So this is an array. This is a 1D array with 4 elements, right? 4 elements. And now you can see I am defining a function here which is declaring, basically the declaration goes display, and I am taking 2 parameters, and the return type is void. That means this function will not have anything which will return anything, right? It is void. So now you can see the name of function is display. So in display, what I am doing, basically I am passing array of 3, basically the third element. This is the 0th element, this is the first element, this is the second element, and this is the third element, right? So basically display will go as 12, and array of 0, this will go as 2. Array of 0 means the first element of the array. Fine. So what will happen, age of 3 will be the, so basically I must have modified this. So this is the FOURTH, fourth and first. So this goes into the printf function. So age 1, right? So age of array, third element, which is 12, gets copied to age 1, and age of 0, which is the first element, gets copied to age of 2. And then we do the sum of ages, will be 12 plus 2, which is 14. Let us run the code. So you can see 12 and 2, and the sum of ages is 14. So how does it work about, right? Just like simply we just passed yesterday, like for multiply functions, we were passing I comma j. So we were passing 2 individual values. Now what happens? Let us come to the drawing board. So here what happens is, so in the main function, you are defining in the main function age array. So you have a main function, you have an age array, which is 2, 8, 4, 12. 2, 8, 4, and 12. And this is integers, right? Let me change the pen color. So now this is element 0, element 1, element 2, element 3. This is indexing, and array indexing, as you know, begins from 0. Now what I am doing, let me change the pen color, and I am calling a display function, and I am passing age array 3, age array 0. Right, and then I am defining the void display function. This is void display integer age 1, integer age 2, and I am just printing the values, right? So now what happens here, let us see one by one. So age of 3 means the third element of the array, which is, this is the third index, so the value is 12. So basically this gets replaced by 12, and age of array of 0, which is 2, gets replaced here. Again, remember that the order does not matter. It is not like the first elements need to be fast first. You can have any order, like we had 3, 2, anything, any order is okay. That order does not matter. What is more important is the element which will be fast first will be copied to the first variable. So age 1 gets 12, and age of 0, basically array of 0, which is stored in age 2, gets the value 2, right? So this is how you basically work with arrays. But if you get the program which you did yesterday on the multiplication, I think this is very, very obvious, right? So in this, we are still passing a single element, right? Still passing a single element. But in this case, we basically make use of arrays to pass the element, right? So I hope this code is very clear. It's very basic also. So nothing to worry about it. And then we can of course do any operations here, right? So for example, just for a quick revision that you want to do. So let me just copy paste this function 1 underscore 1 dot c, right? So if I want to return something, so let's say I make this as int. So this is the function declaration. So same int will go here. Now since I am returning something, I am returning int, I need to return age1 plus age2 semicolon. And now that you are returning age1 plus age2, this function is returning. When the function exits, where it will go? It will go to the place where it was called, right? And here you can declare something integer total age, right? So I can write total age is equal to this and printf slash n percent d, this is total age semicolon, right? So you can see now I'm able to pass it to the main function also. So what changed? I changed void to int. Since I'm returning something of int, I need to put a return statement here, right? If I don't put a return statement, it will pop an error, right? As again I said, some latest compiler, but this will surely, I think this is some issue with the VS code. It should dot slash a dot exe. Okay, right? So always remember, when you are using an int array, this is again a bug like yesterday we saw, but if you are returning something of int type and you comment out the return, it should throw a compilation error, right? A function returning an int has to return something. Okay guys, so the very simple code this was. So let us come back to the second function program, which is basically consisting of array passing. Now you can see here I am declaring an integer balance. So balance is an array consisting of 3000 elements. This is a very huge limit that I have kept, but okay, let us keep it 30. Okay, so 30 elements, and I'm defining 5 elements here, right? 1000, 2, 3, 17, 50, right? So just let me name this index 0, 1, 2, 3 and 4. This is the index 4. Okay, so you get this. So index 0 is 1000, index 1 is 2, index 2 is 3. Okay, let us have some good values. Let me just insert a 0 after it, right? So now what happens here is we have 5 elements here, and in this case what I'm having, I'm declaring something as double. So double has a larger space in the memory, right? Integers usually have 32 bits, which is 4 bytes. Float is again I think 4 bytes, and basically it is compiler dependent whether you are using a 32-bit or a 64-bit, right? So never you can have the direct answer for it. So double has a huge memory space, right? So it can accommodate bigger numbers. So now you can see what I'm doing. I am calling a function get average, right? I have declared the function get average, and you can see what I am passing here. I am passing basically balance, right? I am passing balance here, but now balance is an array, right? Balance is an array, and then along with the array I am also passing the number of elements which are actually stored. See here, if you see, balance is an array with 30. I am not passing 30 here. I am passing the number of elements that I have actually stored. So how many elements I have actually stored? I have actually stored 5 elements, right? I have actually stored 5 elements here. So in this case, since I'm storing 5 elements, I will just pass on 5 values here, right? Now let us see how the function actually works. So in this case, you can see how the function basically, when you define the function, right? And you define the function. Now how does the compiler comes to know whether this balance is a normal variable or a array variable, right? First, from the declaration itself, it knows that it's a balance is an array variable. Second, when you are using it in function definition, you basically provide an empty parenthesis. Now you will ask, why empty parenthesis? Basically, C compiler provides us with this functionality so that we did not even specify what is the size of the array. We are just saying ki, okay, there is something which is being passed here and it's of array type. It is of array type. And second is integer size, right? So what is the size? So size basically will contain the number 5, right? So guys, when we start with pointers, you will understand when we are passing this, actually what we are passing. We are basically passing the base address, but right now just forget about base address and pointer address and everything, right? So let us come back on the drawing board. Yeah, please ask. Yeah. 0, 1, 2, 3, 4. That's it. So array initialization will always start from the index 0. So technically what happens when you compile the program? So let's say one integer takes 4 bytes in the memory. The moment compiler sees the balance array has 30 elements, it will allocate 30 into 4, 120 bytes in the memory, right? Now since you are declaring 5 integers, so from location 0 to 3, that is 4 bytes, it will store the first element. From 4 to 7, the second bit, it will store the next elements. So the rest, basically we have only 5 elements. So 25 elements are like null. So 25 into 4, 100 bytes basically you are wasting here in this case. So this clears your doubt, or you have anything else to ask? That is again compiler specific. In the older compilers, it used to keep random values, but in the newer compilers, it is by default storing 0 in all the values, in all the places, right? So you basically will have the first 5 element will be this, and the rest 25 will be auto initialized to 0. But remember, this answer is again compiler dependent. When I studied C in 2006, it was all random initialization, garbage values basically, right? But in recent compilers, I have seen that they basically auto store 0, right? So the answer, exact answer is compiler dependent. Older compilers, garbage values; newer compiler, 0 values, right? हाँ, ask. हाँ, बोलो. See, basically, this concept will get clear when we do pointers, right? So what happens, as I said, okay, just let me show you an initial diagram. We will do this. Okay, did Saurabh sir start with pointers by any chance? Acha, okay, so I'm just telling you a very small example. This is just like so that you can understand a little bit, right? But when we do pointers, we will do this in details, right? So when I'm saying balance 30 is equal to 1020, 30, 170, and 50, right? This is my balance array. So when I have 30 elements, that means 0 to 29 I can have element, right? So assume this is 0th element, this is first element, this is second element, and this is 29th element, right? So when this guy executes it, somebody please mute your mic. Okay, so now what I am having 29 total 30 elements, and in this case, let me change the pen color, right? So in the first location, we have 1000, then 20, 30, 170, 20, 30, 170, and 50. These are the elements that I am storing. So the rest, for example, this will be element number 3, this will be element number 4, and the rest will be, let us assume right now, is all zeros, right? Newer compilers all keep zeros here. Now, when you pass something like the balance in the function, so we are, let's say, having, what is our function name? It is get average and balance and 5. So we are having get average, balance comma 5, okay? And this is basically a part of main. And then we do get average. I am doing integer array and let's say integer size, and I do some operations here. So let me change the pen color. So what happens, balance is an array that goes here and we have empty parentheses, right? I will tell you what is the logic here, and then 5 will basically get to the size. Now there are two sizes. If you see, we have a base element of 30, right, which is not required because we have only 5 values, so we are actually sending only 5 here. Now when we have balance and we have integer array, so technically what happens, see, everything that is stored in a computer system, anything that you do, you store movies or something, they are stored either on the hard disk or while when the program execute, it is executed in the RAM, right? Everything which is stored has a memory location. Now from memory location, you just realize that each of you has a home, right? And every home has a specific address. No two homes in India will have the exact same address, right? Even if it is the same building, you will have the different flat numbers, flat 1, flat 2, flat 401, 501. Same thing happens when we basically deal with memory. And when you have studied arrays, you actually understand that elements are stored in a contiguous memory location. That means one after the other in a logical fashion. Now what happens when you are passing this balance? So now let's say there is a random memory location with the number 98,000, right? So memory locations in computer are just numeric things, right? So let's say the memory location is 98,000. Okay, starting memory location 98,000 in RAM, I will be storing this balance array consisting of 30 elements. Now 30 elements, how much space they will take? Assuming a 4-byte integer, they take 120 bytes. Okay, so now when you have 98,000 at the starting memory address, so we will have 98,000 plus 30 into 4, right? So from 98,000 up till 98,120 will be the total memory location basically used for storing the 30 integers, right? So now remember, this address, this 98,000 is compiler specific. So on every system when you execute, it may have a different location which is empty in the RAM, right? So it will give a random base address, right? It will give a random base address. So when we are actually passing a balance and we are collecting as this, so what we are passing, actually we are passing the address here. We are passing 98,000 in this thing. Always remember, whenever we are passing arrays, we are actually passing the base address of the array. Now you will say, how do you determine that? Okay, from the base address, how can we know our element location? Because array has the property that array elements are stored one after the other, right? Now you will say, then how do we determine that? So now basically that my array consists of integers. My array consists of integers and every integer is 4 byte. So if the starting location is this, the element next will have a location of plus 4 because it is taking 4 bytes. So 9804 will be the second element, from 9804 and so on, right? So get the idea. So when we do pointers, we can get a more feel of it. We can actually display the exact address which is stored in the memory. That again will be different for different machines, but the logic remains the same, right? So for example, if it is a character array, how much, do you know how much character occupies in memory? Anyone? Yeah, exactly. If character occupies 1 byte in the memory, and let's say this was, instead of int, this was a character array, right? And the address, let's say, was 98,000, then what the compiler will do? Plus 1. Then it becomes 98001 and so on, right? Let's say double, it takes 8 bytes. So 98,000 plus 8 plus 8 plus 8 plus 8. even if the element is small, it will actually occupy that space only, right? So for example, integers are 32 bits, which is 4 bytes. So 2 raised to 32 is 4 GB, right? 4 into 10 raised to 9. So that is the highest number that can go into an integer space. So whether you store 4 into 10 raised to 9 or you store int I equal to 1, both actually occupy 4 bytes in the memory. So this is basically the meaning, right? So basically what happens whenever we are passing something of this sort, right? We are basically telling, okay, I will have the base address something like 98,000, and I know that the data type is integer. So I know the jump also 44444. And when I'm specifying the size, now what is the use of this size? See, you are defining a balance array with 30 elements. Technically, I can access 30 memory locations, but my actual number of elements are 5, right? My actual number of elements are 5, and because of this you can actually run a for loop where size is equal to 5. So in this case size is equal to 5, and then I can traverse all the elements in the array. So how to compute the average? First I do the sum of all the values and then sum divided by size, right? So average in this case is 254. I think if you compute yourself, it will basically come out the same thing. So this was the main point. So whenever we are passing an arrays, a obvious question in this case is, whenever we are dealing with arrays, is it necessary that we have to pass the size of the array? No, not required. We will see that when we do pointers, this is actually not required. There is a thing called pass by reference, and in that pass by reference, we actually need not pass the size of the array. But for today's tutorial, since we are starting with arrays, right, just remember that, okay, we have to pass the size also of the number of elements that we are actually inputting, right? So guys, it is like 20 minutes from the lecture. It is 12:25. Let us take a break and we will return in 5 minutes. We just have a small break. So see, in this case, you are getting 1852466. See, random values, right? So hence I said avoid such kind of experiments. Your code will break. That is it. So this was int, this was character, and this was again int. So first of all, something weird has happened. Oh, thank you. Int balance. Perfect. Thank you. This is 254. Let me ask some chat. Uh, Shailendra Mishra, you can try this, but I really don't think this may work. You can just try it out, right? As again I said, these all shorthands are compiler dependent. So it is always better to follow something, which is tried and tested. With C, it is always the risk, right? GCC versions and all those versions have a lot of difference. But you can try it. Always good to have some knowledge. So this is here, and now function array 3. Okay. So this basically is an example for passing 2D arrays. Right. So 2D arrays basically you must have studied in the form of a matrix where we have the number of rows and number of columns. Right. Number of rows and number of columns. Guys, I'm just pausing for a second. Yeah, guys, sorry, I just got a call. So, Prakhar, it is a library. Yeah, stdlib.h basically is used because I'm using the system call. So, for that, stdlib is used, not for anything else. Okay. So, it is not array dependent. Array for that stdio is enough, right? So, now let us see how do we pass a 2D array in a function, right? Again, a very simple code only. So, in a 2D array, basically what we are dealing is, so we have declared a 2D array. You can of course have an n dimensional array. So 2 cross 2 is basically just 4 numbers because 2 into 2 is 4. So I'm asking the user to enter 4 numbers and then just standard, right? So if you have k dimension, it will be k for loops. So we have 2 dimensions, so we are having 2 for loops. So I store all the numbers in the num array. right? So now in this case, so whenever you are passing a 2D array, right? So in this case, you can see that I am actually calling a display functions, right? You can now observe that to the left of display, there is no variable. So automatically you can come to know that it is a void function, right? It's a void function. So when we have display numbers here, so now you can see how I am catching in this form, number 2 comma 2, right? Numbers is 2 comma 2, and I'm just displaying the values. So in this case, now you may ask that, okay, because see my array is also 2 cross 2, I am taking elements in 2 cross 2, and I am just passing the array 2 cross 2, right? So technically, if you see, instead of specifying the size, I am indirectly specifying the limit of my array here itself. So there is no explicitly, actually we need to pass the size of this array. So let me just run the code. So enter four numbers, let's say 5, 7, 8, and 9, right? So we are just displaying the values 5, 7, 8, 9, right? Let me just try one more thing here. Enter four numbers, 5, 1, 2, 4. Yeah. One important thing to remember in case of 2D arrays is that it is okay if you don't specify the first dimension, but it is mandatory that you need to specify the second dimension. Now it is very logical also, right? So for example, let's say this array, if you don't even pass this, right? So what was your base array? Your base array was 2 cross 2. Now I can represent 2 cross 2 as 1 cross 4, 4 cross 1, and 2 cross 2, right? I can represent this in multiple forms. So how will the compiler come to know whether this array is a 2 cross 2 or 4 cross 1 or 1 cross 4? How does it come to know? It cannot come to know, right? But the moment I write a 2 here, it knows that, okay, the third dimension has to be 2, second dimension has to be 2. So this gets out of the question, this gets out of the question, and only this remains. So either you specify both or you do not specify the first one. But specifying the second index is mandatory for 2D array. Usually we never require 3D arrays, right? It is difficult to comprehend also. But 2D arrays are good. For example, when you do matrix multiplication, you would require a 2D array to work upon. So this is how you can pass a 2D array. Remember, passing 2D array, you can just pass the name of the array, but mandatory dimension, well and good. But from the second dimension, the first dimension is auto computed just by dividing the original array, right? So that is it. So this was all about functions and array. Let me just see which is this program. Okay, this is another simple program only. So we will just see this program and today's lecture we will end. Right, so I am defining a max function which inputs two numbers. Again, if you see, the return type is int, and since the return type is int, you will see that when we are calling the function, we basically store the value in a variable. Right, we store the value in a variable. So here in this case, what is happening? A is 100, B is 200. I am passing max A and B. So what will be passing? We are passing 100 and 200. As I said yesterday, when you are passing a max function, the execution of main is paused. What happens here? 100, 200, and we are storing the result, right? So let me just remove this. These are unneeded lines. So if num1 greater than num2, so if 100 is greater than 200, which is false, it will come to the else part. So what I'm storing in result is number 2, which is nothing but 200. So it will return 200 to the main, and we will display the max value. You can see max value is 200. So now let us see some terminologies associated with functions. So terminologies means, for example, whenever you are declaring something in the main, right? Let's say main may you are declaring A and B. So this basically is known as actual arguments. These are the actual things that you had actually declared, right? So when you are calling A and B, these are basically known as actual arguments or actual parameters. In different textbooks, you will have like different words for it. Some say actual arguments, some say actual parameters, right? So A and B both are actual arguments. Now when we pass this to a function, right? So what we are doing, we are copying the value of A into num1, we are copying the value of b into num2. So these are known as formal arguments or formal parameters. See, these are just like terminologies, right? But just for knowledge, because sometimes when you read about these functions online, they actually say, okay, when you pass formal parameters, these happens, that happens, and all those rules. So these are, so basically in the function call, in the function definition, they are basically formal arguments, and in the function call, it has actual arguments, right? So what is a local variable declaration? So this result variable is a local variable which is declared for the function max. So you cannot access this result outside the max function. That again we will see in another chapter, that we define the scopes of variable, right? So not now, right? So you already know this line is the function declaration. We are calling the function round parenthesis. The actual values which are passing from the main are known as actual arguments. The values which are copied to function variables, these are known as formal arguments, right? So I think that's about it. So today's lecture, we can just complete it right now. So I'm dividing my lectures into small parts so that it is not too overloaded to think and to solve. Earnest request to all of you is that install Dropbox. I have sent the instructions over email. Read this directory, clone, and then try it yourself using VS Code. As long as you see on my lectures, everything will seem easy, but keep on trying different things, right? Like I'm so happy that there are so many doubts that are being asked, and it will happen that I may not be able to answer all your doubts, right? Programming is like infinite. You can never know all the answers to everything. So better start your system, execute the code, try out different things, just see that, okay, this is working, this is not working, and all those stuff. Right, class? So thank you for attending the class. So I'm stopping here and I will share the YouTube and the recorded links in a while. So where can we practice from? Let us see book you can search, and in the description of the video I send you the garbage value, some website is there. The solutions are there. So you read the question, try to solve yourself. Let us see by Yashwant Kanetkar, and then you can see the solutions there.